So thank you for your knowledge and your work. Let's move on. We move to Mr. Daniel Kopkáně, Ph.D. from the Czech Republic. Please, you can come here. We will applaud you. Hello. Are you from Moravia or from Czechia? I'm from southern Czechia. I think I'm already from Brno. I'm only ask you because always when I listen to the several English accents, I really like when somebody abroad asks me,
how do you know that I'm from Prague? Just because
the host is now showing very strong Czech accent, so I will proceed my presentation in the Czech language. You are an expert in thermal radiation and its influence. You are from a technical university, Vysoké učení in Brno. And you are an expert in a lot of stuff, yes? Well, I understand something. So what's your topic of today's presentation? I've been dealing with the heat island of a city and how we can approach this with the infrastructure that we have, the distant or the remote research. This remote research sensing is very interesting. I really liked the previous one. We have satellites, we have stationary ones, then we have the ones in orbit, then drones, planes, cars, or even some scanners on foot that you can wear inside or have inside your building and get interesting data. What we have in our institution, when it comes to remote sensing, it's very interesting infrastructure by this plane with cameras. They also have infrared radiation, so we can also create this layered with emissions, which is not possible with a common camera. We also have there a laser scanner, radar, and from that we can create different layers, and then we create further data layers which are deeper analysis. So I would like to explain you how we do it and what it can end up with, and maybe we can start cooperation. So this is what you know. This is from like the plane, the visible RGB. Then we have the visible and near infrared. So what is different here when it comes to color on the right and the green? Yeah, the greenery is red here, which is weird. Yes, the reason is that the green reflects very much in infrared, near infrared. And here we have surface temperature and emissivity. And this is one thing that thermal cameras don't really do. So always when you work with infra camera, you have to set an emissivity. And we can assume this emissivity for each pixel, and we calculate with a certain preciseness, and we know what is reflected, because we usually see it from above. Normally the sky is reflected. Then the metal roofs are cold, but if you don't correct your emissivity or adjust your emissivity, the data can end up a few degrees less or more. Let's say on the metal surface it can be up to 30 or 40 degrees. So I can have it can show that here it is cold, here it is hot, but the temperatures are not very precise. But when we do this complex analysis and adjust the emissivity by the algorithms, we are able to guarantee a certain temperature for certain surface with a deviation of approximately half a degree, and we can be precise for up to 1 or 2%, from up 1 to 2%. We trust it because we use system working in certain way. The heat, the sun is shining on it, it gets overheated, and there are some crucial parameters. However, the emissivity is a structure, it's an ability to absorb the energy, and therefore we can describe the structure, we can describe the emissivity and albedo. And we can also estimate the materials, so it's quite good to understand that the materials such as concrete or asphalt or also roofs have a bit lower ability to radiate in comparison to greenery and water. They radiate a lot. Asphalt and concrete have this ability lower by 5 to 7%, which means they keep the heat for a longer time, and that's also reason why the cities are hotter, because they absorb the heat and they radiate it more slower. And this is what is behind this heat island as a phenomenon. So why hyperspectral sensor is so good? So when you have the thermal camera, so you have something which you can perceive by your eyes, but our sensors can divide this into 120 channels. Therefore, we are able to create curves describing the procedure of a certain material, so to say. Here is the greenery. So this is what the juicy, lush greenery looks like. Why green is green? Because here it has more reflections in this part, which corresponds to green part of the spectrum, because the plants use green and blue part of the light, and therefore they can use the photons of the energy, they can create sugars by photosynthesis. So, but what happens with the other half of the light that we don't see? So not to get overheated, because they are not used, they learned to reflect the energy. And we learned to see it in such a manner that we are not blinded, because what you see previously with the green and blue, that it's more reflected, not to be overheated. When we saw in this section everything, the green would look like light gray to us, and this would make us, this would blind us. So this is kind of an evolution dance, how we adjust to environment, and it all suits suits together. So here we have other construction materials. The number corresponds to 3 is concrete, and then there is albedo, which is the average through this line, which is the sunshine on the surface. So this is the curve for the surface of sun filtered with atmosphere. So therefore you get the value how much the material absorbs or reflects. Depends. And this is important to calculate albedo, so that we see how these materials in the city will function. Concrete will have albedo less than 10% generally. I mean, not the albedo, but the reflection rate. This normally in the beginning it has 4, but after some time it has like 12%. Interesting are those roofs. You can see it placed nicely in this red part of the spectrum. it seems red. And here we have two curves for black. This one is glazed, and it shows that some materials have like spectral selectivity, and they only reflect certain parts. So by albedo they are lighter than they seem optically. I think the producers do not promote this very much, and they could, I believe, because we want to make the cities lighter, not to get overheated. What we can also do is that from these curves for greenery, we can very well define and specify how healthy the plants, the trees, the greenery are. We can also estimate the volume of chlorophyll, water, how much the greenery has, how moist the greenery is, how lush it is, and this is used in agriculture. By these curves, you can learn or you can see what are the shortcomings which you cannot see with your eyes yet. So we are coming to that. Another aspect is the synergy of our instruments, FLIS. I just want to have one small remark on satellite. Today they have we have quite a small resolution. But when you see this picture, this resolution is like 500 meters a pixel, I think. So when we scan with our plane, we have the pixel of 1 or 2 meters, so we can get to the level of streets. And when we combine it all together, we can create this profile, which is classified. However, in 5 months we are starting the project Albedo, which promises to have 2 meter thermal pixel, 14 days of revisit times, which means that within 14 days, when there are no clouds, you can get a picture of some city for a certain amount of money. This will be interesting, but the satellites will still not have the spectral resolution that we have, so we are not worried about our jobs. What we can do with the classification, so this is the city, the housing area, and this is NDVI, as you can see. It's normalized difference vegetation index, and this calculates with the reflectability of these parts, and it tells us how green the greenery is, how much moist, how much hydration it has, because when it stops to function, these conditions change, and you can see it here. You see that the river or the houses have the low index. Then, thanks to radar, we can see the height of these buildings, and you can create these classification trees, and they check each and every pixel, whether it's elevated or not, whether it has a great absorption ability or not. Here we have water, whether it's the road or grass or water, buildings, trees, and so on. And then we have these pictures, which you have already seen, but now you know more about them, how it works. So this is the red are houses, the dark green are trees, orange are roads, light green is grass, and blue is water. And this is in thermal picture. Red is, sorry? What can you see? Those are the roofs. The red ones are the roofs. So the roofs are reasonable to address, for sure, but if you look at it from the satellite point of view, there is one shortcoming, that this big pixel will make you the average for the entire surface. But when we address, or when we ask how the life is on the street, from the heat comfort point of view, it shows that these roofs have only 1/4 influence on you with this temperature, because if you have a flat roof and you walk the street, what radiates on you is the wall, is the pavement, it's the lawn, and somehow also sky. And the sky and the entire city is reflected in the sky, so to say, and it shows that 80% of the radiation is caught in the first 100-200 meters of atmosphere. So I feel on the street this roof, maybe also this river, but not this area doesn't affect me very much. But those are the things that you can work on because they're interesting, and I think it's necessary to be able to divide those, and our precision can do that. I would also like to show you this aspect, because the question is what we can do with adaptation in the cities. And I believe that the very neglected potential are the green grass surfaces. A few years ago, this was very much discussed. What's the optimal way of maintenance of greenery? And we made a small campaign during summer, for radio and television, and it was very nice because we put a call. We said, in Brno, take a picture of your lawn in your area and tell us where it was. And this is the cross-section of various lawns, and you can see the differences. Number one has more than 50 degrees, and it can be it's comparable to the road, to be honest. And a good lush lawn has the temperature of, let's say, up to 34 degrees. So what does it mean? So when we consider how many surfaces, green surfaces we have, the good management of these surfaces can do the same as if we painted roofs white, which would also be possible, but maybe it's easier to do changes in greenery management. I'm not an expert for lawns, for grass. I'm expert in heat radiation, but we started a cooperation with the maintenance of greenery, of the grass. So what we can do, we can take the information from our data that can be helpful, and what has proved good is to use one special element of our radar, because it not only sends a ray, but it can also measure the rate of a pulse, and therefore you can also estimate the height of the lawn, of the grass. When you are in some empty room, there is some echo when you make some noise. If there are no surfaces, the sound is kind of hard. If there is something softer, the quality of echo is different. And this, to a certain extent, applies to this leader pulse, and up to 10 centimeters, what we are able to say. There is no grass, there is certain grass, there is some grass, there is high, low, and then we can do the analysis. Okay, this is what it looks like. Those are the measuring points: 68, 93, 94, 95. We classified the height from the leader, We put there the temperature, we check the DVI, and what is the optimum height for the lawn, for the grass. And this is the basic output from 100,000 points. And it shows that 10 to 20 centimeters could be optimum for grass, for the lawn, which means 15 centimeters or 20 centimeters still don't look bad, and afterwards, or if it's more or less, the temperature starts to rise. So there are also some other conditions, but I still believe this is very interesting information to be provided to the maintenance of the grass, of the lawns, and one way what you can do with this data from satellites, how you can analyze the data. So let's check, or let's move back to Brno. This is the Sentinel project. And I only do it through Google Air Engine, and where we can check the differences among the months. And for the future, there is this idea to discover whether there is some difference or some relation. How was the temperature in Brno, and how was the height of the grass in Brno? So, and these are the outputs from the previous observations, from the previous shooting. So this is land surface temperature, this is RGB, and this is the gradient, proxy temperature gradient, which is estimated from the tree temperature, and it's kind of experimental approach. However, it can show you what is this heat island and how much the temperature, air temperature is increased. And when you calculate the temperature of surfaces together, which affects us when we walk the street, we can create this map which tells us how much is the real temperature that you feel. You may say 30 degrees is a normal day, but in the city center it will be 40 on average, and in the woods it will be much less. Okay, that's the end of my presentation. Thank you for your attention. I was expecting more from you, to be honest. I'm happy you are laughing, that's quite important. I thought that there was some after-lunch coma, but I think that this must have woken you up because so many colors and maps, and I'm just a normal person with very average education, and I have a cottage in Banská Štiavnica, and I go there once in a time. I go to mow the grass, and I don't know why. I used a lot of water from my well, and my grass was quite nice. And then I wasn't there for a certain time because my children were born, my twins were born, and I didn't go there for 6 to 7 weeks, and the grass grew to almost 30 centimeters, and I never understood that the the height of grass can have impact on the temperature of the entire city. I'm sorry for looking like an idiot, but this is completely new thing for me. The grass has this beautiful effect that it can shadow the ground, and if there is no grass, it can absorb and accumulate the heat, and when the sun sets, the temperature drops. However, the concrete keeps the temperature until the morning. So that's interesting information. I'm happy that you monitor stuff like this. So I will keep my finger crossed. Also, you are a member of Czech Academy of Sciences, so it's been a great honor for me.